Okay, welcome back. So in this video, ang topic naman natin is another divide and conquer algorithm called merge sort. So yung merge sort natin, since yung na-encounter yung sorting algorithm so far should be at around of n squared, yung kanilang time complexity. Kasi yung pag-pass through ng kada element is multiple times. So here we have a divide and conquer approach in sorting called merge sort. So yung ginagawa ng merge sort, so yung gist of it is we partition the list into, I guess yung simplest is two partitions, and we sort the lists separately. And if we have two sorted lists already, mas madali na silang i-combine to form to get the biggest sorted na list or yung eventual sorted na list. So for example, yun nga, nag-partition ka na ng dalawa, na-sort na sila. And pag kinombine mo, kailangan mo lang hanapin yung minimum element sa kanilang dalawa. And yun yung ilalagay mo sa eventual na final na list. So yun. So pag alam mo sorted naman na sila, mas madali siyang i-combine to form the big or the eventual list. So paano natin sinusort yung dalawang partitions natin? So, ayun, as you may have guessed, since this is divide and conquer and we use recursion, we sort the partitions using merge sort then. So, actually, if titignan from the start, yung ating recursion, magsa-start siya with each element having its own partition, and then kino-combine lang natin yung mga magkakatabing partitions. So, yeah. So, meron tayong 4-element partition. Ito is 3-element partition. And eventually, yes. So, eventually, umabot tayo sa point na yung partition is isa or dalawang element lang. And madali lang yun sa atin for us to sort since konti lang yung elements. And eventually, by continuous combining, we eventually reach our fully sorted list here. So how does that look in code? So ayan, ito yung merge sort na recursive function. So meron lang tayong konting debug statements dyan if ever gusto nyo i-run. And ayun, we just find the middle element. So we just get yung n or yung length ng array over 2. So integer divide para sure mo. Integer. And then we just apply merge sort dun sa left subarray and then yung sa right subarray. So recall yung pag-partition natin or pag-slice natin ng Python list. So dito is from the starting element up to the midpoint without including the midpoint. And then this one is from the midpoint hanggang sa dulo. So it's important na hindi kasama yung midpoint dun sa left partition. Although pwede mo naman gawin na included siya, pero wag mo siya include sa right kasi magdo-double siya lang. So basta yung midpoint is nasa isang partition lang siya. So we get isa-store lang natin dun sa left yung sorted na left partition, and then sa right yung sorted na right partition. So and then after nun is we call the merge function to merge yung dalawang sorted na list. So yung merge function, so assuming we have two sorted na lists, is we combine them to make a super list na sorted din yung kanyang laman. So ang kailangan na natin gawin is, ayun, habang may laman habang may laman pareho yung dalawang lists natin, A and B, we just get whichever is yung smallest. So if A0 is smaller than B0, we remove A, or we remove the first element of A and append it to our temporary list over here. And then, ayun, kung mas maliit si B yung ilalagay natin sa temporary na list. So yung pop operation natin, if hindi kayo familiar, it removes the element at the index na naka-indicate, and then it returns it to be appended din kay temp naman. So, ayan. So essentially, it's doing yung nakikita natin dito kanina. So, going back. Ayan. So, yun, compare 2 and 4. and 2 and 14, mas maliit si 2, so we pop it. So yung pag-pop is mare-remove siya doon sa current na list na yun, and then may insert siya dun sa temporary list na yun. So you can imagine this as this one is yung A, and then this one, the rest here is yung B, and then dito sa baba yung ating 10. And then ito, pag bumaba siya doon, that is our pop operation. So pag tingnan natin, pag nag-pop si 3, bababa siya. And then next is magpa-pop si 5, and then pa-pop si 14, and so on and so forth. Now, since alam natin na sorted sila parehas, ang kailangan na natin i-compare is yung first elements nila. Kasi yung, since sorted na sila, yun na yung smallest element so far for both lists. So yun, pagka na kuha na lahat ng elements from one list, basically, if meron pa natira, is i-append lang siya sa dulo ng temp and i-return doon sa earlier function. So ang i-return nitong merge sort is a sorted na list or array. So yan, if we have this list, you can see na masasort siya. Ay, well, hindi pa pala kasi hindi ko pa nararan ito. So hindi pa siya masasort. And so, pag naka-true yung debug mo dito, is makikita mo yung internal steps ng pag-merge sort. So, before sorting, ito yung laman ng ating array. So, we call merge sort for this complete list. And yung merge sort natin starts with the first half. And then hati niya ulit. And then eventually, makaka-reach yung point na isa lang yung element. So, which is the base case pala. Kasi the convention it. Yung base case natin over here is pag walang length or wala nang naman yung ating partition. So, return lang tayo. Then, ayun. So, after makarating sa tatlong elements, yung partitions natin have 1 and 2 elements. Yung 2 elements, madali lang naman i-sort yan. Sorted, mapapartition pa pala sila into 1 element arrays. And since 1 element na lang sila, is sorted na siya. So we just merge these elements. So we have 38 and 44, and then i-merge siya with yung 3. So we get yung 3, 38, 44. And then, ayun, so yung first half nito is dito si North. And then yung second half naman, yung list is dito pa siya masasort. So magka-level naman sila. So makikita nyo lang individual steps ng pag-sort. And eventually, sa dulo, we have a sorted list over here. And then, ayun, if ayaw nyo naman makita yan, pwede nyo naman gawin false to. And then, yun lang ipapakita niya before sorting and after sorting. So, yung ating function, actually, may tinatawag tayong helper function. And siya yung nagpo-call ng recursive function na nasa loob niya. That is usually done in order to help our recursive function. Kasi minsan, when we implement yung ating recursion, meron tayong mga initial na arguments na pinapasa. And yung ating helper function, siya yung nag-determine nun. And if, for example, hindi valid yung input sa ating function, pwedeng i-stop ng helper function yung pag-call ng recursion. Kasi baka hindi natin alam ano mangyayari. Kasi recursion siya if hindi valid yung input. But in either way, I guess this just yung text natin dito just explains how the algorithm works. So, yung recursive na merge sort is called twice for each partition. So, yung colon mid para dun sa 0 hanggang mid minus 1 na element, and then from mid to the last element is yung other call. And then lastly, yung merge function is merge It merges yung ating left and right partitions na sorted using merge sorted. So, ayan, since ito meron tayong implementation, we can get its time complexity. So, yung ating recursive na in ating recurrence relation would look something like this. So, meron tayong 2 times t to the n over 2. So, saan to galing? So, si p of n over 2, siya yung recursive function call natin over here. And may times 2 siya sa umpisa kasi, ayan, twice natin siya pinakall. So, assuming na yung n is large enough, approximately equal naman yung dalawang partitions, so we can say na times 2. And then, ayan, so recall, pagka if siniset up natin yung ating recurrence relation for a recursive function, yun nga, yung recursive call yung una, and then yung other parts ng recursion. So, yung other parts ng recursion require the use of the merge function. And, ayan, so for now, lagay natin yung time ng merge operation. So essentially, the time it takes to implement the merge sort for n elements is 2 times yung time ng merge sort for half the elements plus yung time ng pag-merge. And plus a constant amount of operations para dun sa ibang parts ng ating function. So, in order to get yung ating time complexity or yung running time ng merge is, yun, tignan natin ang ating merge function. So, meron tayong isang while loop dito, which will be the source of additional or non-constant na time complexity. So, we first assume na yung operation ng pag-pop at saka pag-append are of 1 or constant. But baka hindi siya, pero for the purposes of our lecture or for our discussion, they are of a constant na running time. So, kailangan natin malaman kung ilang beses ba mag-run yung loop na to. So, ayan. So, yung the number of times na mag-run siya is dependent doon sa length ni A and si length ni B. And at the worst case is mag-zero yung isa pag 1 yung isa or mag-zero sila at approximately the same time. So, which means na eventually from starting at, di ba n over 2 sila, n over 2 minus 1, and then kasi di ba, for example, nag-start ka 10 elements si A, 10 elements si B, ayun, up to 19 times uulit yung ating loop. So, yung combined length ni A and length ni B, pag in-add up natin, siya yung number of iterations ng ating loop. And recall, pag kinocall natin yung merge function, yung dalawang list natin is from the partitioning ng ating divide and conquer algorithm. And since pareho naman silang half ng array, so we get n over 2 for each of them. Pag kinombine, maybe n. So, n times na nag-repeat yung loop, we get a time complexity for merge as O of n. So, rewriting yung recurrence relation, well, pwede naman natin tagalin yung big O and n na lang lagay natin. Mas madali yung math. So, we get this recurrence relation. And using the recursion tree, ayun, pwede natin pakita dito yung ating running time per level ng ating recursion tree. So, at the top of the recursion tree, yung ating non-recursive na running time is n plus c1. And then, yung dalawang recursive call, may n over 2 plus c1 at saka n over 2 plus c1. And then, ito, ito-call nyo si n over 4. So, may n over 4 plus c1, and so on and so forth. And then, you'll notice here na yung total number of n per level actually stays the same at n kasi na-half siya per call pero twice naman natin siya kino-call. So, ayun. At each level, we can assume na meron tayong one whole n term. And then for the constant term naman, you can see na since constant nga siya, hindi siya nagbabago. So we just have to count kung ilang functions ang meron tayo per level. So since yun nga, as in yung merge sort natin makes two partitions, so dalawang decision magkakaroon ng recursive call. So magdo-double siya every time or 2 to the level na number of functions in a level. So ayun, then for the last level, you can expect na after ilang partitions ba to? After 2 to the depth na partitions, we are uh, left with a P of 1 and ayun, meron tayong total of n na elements. Because yun nga, similar to binary search, yung ating partition length, tumitigil yung ating recursion pagka yung partition reaches one element. And then, because of that, n over 2 to the d, or depth, is approximately 1. So yung depth natin is log of n. So, and getting yung total na summation ng running time per level. So yung unang 2 to the d dito is yung last level ng merge sort. And then we have the summation ng ating per level or n to the k. And ayun, so si 2 to the d equal siya kay n eventually. So just add annotations. So n over 2 to the d equals 1. So si 2 to the d equals siya kay n. So eventually, so nc2 siya. And then our summation over here, pwede siya split into two parts, yung linear or yung n term. Multiply lang natin siya sa total number of addends dun sa summation. So we get d times n. And then itong 2 to the k na term is actually simplifies to 2 to the d minus 1. So simplification to ng summation. So we have yung 2 to the d maging nc2. And then we have d times n. And recall, d is equal to log of n. So this is the second term over here. And then 2 to the d is equal to n. So this is just n minus 1. So eventually, we are left with a expression na n times a constant, tapos n log n, and n times another constant. So yung ating time complexity actually results to n log n, or what we call log linear time complexity. And if hindi po masyadong obvious, that is better than yung O of n squared ng mga sorting algorithms na na-discuss previously, like bubble sort, selection sort, and insertion sort. So ayun, we actually found a sorting algorithm that runs in faster than quadratic time. However, ano yung cost ng pagkakaroon ng mabilis na running time? So similarly sa binary search, yung ating space complexity is no longer constant because we use recursion. So ating space complexity, since dalawang functions yung kinoconsider natin, so yung recursive call at saka yung pag-merge ng dalawang list. So first is yung memory for recursion, similar to dun sa ginawa natin last week, wherein we show yung ating program stack or yung depth or yung isang path from the top level to the deepest level ng mga functions sa tinawag, and yung memory na consumption. Yeah. So starting from merge sort na n, we use extra memory for our function by dito sa dalawang operations na to. So yung ating dalawang partitions is we store them in temporary lists or variables. So ito yung extra space na ginagamit natin for function call. And yun, total memory na ginagamit nun is 2 times yung n over 2. And then for the succeeding calls, yung n over 2 naging n over 4, n over 8, n over 16. Kasi since isang path na yung kinoconsider natin, so isang path na yung kinoconsider natin over here, so basically, nakukuha lang natin yung half ng memory consumption. after each recursive call. And then if we take the total over here, so it's D times C1, since lahat sila merong C1 na memory for every other uh, variable na ginamit na constant to space. And then for the additional na list, that's 2 times n over 2 to the k minus 1. So starting from 0, dito yun. And then eventually magiging wala, or I guess very approximately 0. So this term simplifies to 2 minus 1 over 2 to the k. And then yung d natin dito is just equal to the depth na nakuha natin previously, which is log n. So yung C1, dC1 is magiging C1 log n. And then yung 2 to the k natin dito becomes n. So, and so distribute yung n na to sa subtraction. So 2 times n, and then C2 over 2 to the k, and then C2 to the k, recall na equal lang to pi. So n over n term siya over here. So we have C1 log n plus 2n minus 1 C2. So yung ating overall space complexity or extra space for recursion is actually log of n. Okay. So yung ginawa pala dito muna is kinuha muna yung memory or space complexity, no merge operation. So we already have yung memory ng ating recursion. So kailangan natin yung sa merge. So looking back sa ating merge operation, we have another temporary list here. No, temp yung pangalan. And you can predict naman na yung overall length ni temp at the worst case is yung combined length ni A at B. Kasi nga, di ba, nililipat natin yung elements ni A at B din sa temporary list. Eh, since si A at saka si B is just yung dalawang partition, so at the worst case, yung ating space complexity for it is O of n. So, pag kinombine natin yung memory for recursion and yung memory for the merge operation, we get log of n plus 2n plus actually c, or plus 1 plus n. And yung biggest growing term natin dito is yung n. So this means na actually yung ating log linear na time complexity, yung faster na time complexity natin, is achieved by using a bit more memory na in this case linear naman siya. Yung sa binary search kanina is logarithmic. But this is actually for our specific implementation of merge sort. Then actually merong mga merge sort implementations na log of n, yung memory complexity, but it will be a bit more difficult, or it requires a bit more optimization, and baka hindi na maging obvious na merge sort siya. But in any case, yun nga, yung naka-verdict natin dito is that similar to binary search, by paying a bit more memory, we can get a faster na algorithm. So this has been yung ating second example, which is merge sort. And for the next video, we will have another divide and conquer algorithm that looks for the maximum subarray. So see you in the next video.